So today we want to look at the domains and of course the general questions on the range. So the question of how do I respond? How do I respond when I'm asked to find the domain of a function? Should be looked at from these types of functions. The first one is a fraction, h of x over g of x. The second one is f of x is equal to the square root of h of x. Like that. The third one is equal to f of x is equal to the square root of h of x plus the square root of g of x. The fourth one is f of x is equal to the square root of h of x divided by the square root of g of x. The fifth one is f of x is equal to the square root of h of x over g of x. The sixth one is f of x is equal to maybe a normal h of x now over a plus the square root of g of x. Let's also talk about the other one. F of x is equal to h of x divided by the square root of g of x. Okay, so these are several types. And this is where you expect to be asked to respond. Find the domain and the function falls in this family. What is your response? How do you respond then? For the first one, your target is the domain is this x belonging to all real numbers. All we don't want is the denominator to be equal to 0. Whatever denominator is given, you don't want it to be equal to 0. An example. So this will be used for examples this side. If you have a function f equal to x over 3 minus x, we do not want the denominator to be equal to 0. So you say the domain here is x, a real number, such that x is not equal to, we know that if x is equal to 3, so now we get 3 minus x and say this must not be equal to 0. Okay, meaning that negative x must not be equal to negative 3. This further means x must not be equal to positive 3. So x should not be equal to positive 3. Like that. Okay? So x must not be equal to negative 3 is our domain. That is a direct explanation of what part 1 means. Part 2, you want the domain x to be any real number. All we want is that h of x should be greater or equal to 0. So f of x must be greater or equal to 0. for this one. An example, you say, okay, find the domain of the function, the root of x minus 4. What is the domain there? It's inside the root. So we know if we have a negative value, we have issues. So we want the domain to be x any real number such that x minus 4 is greater or equal to 0. That is x a real number such that x is greater or equal to 4. Like that. Okay? The third one is the domain is going to be x a real number such that h of x should be greater or equal to 0, and also g of x should be greater or equal to 0. An example there, if f of x is equal to the root of x plus the root of x minus 2, the domain is going to be x a real number such that x is greater or equal to 0, 1, x is greater or equal to 2. And then you get the intersection of these. So we have, if we put it on the number line, we have 0 here and 2 there. This one says from here going this side. This one says from here going this side. Then you get the intersection of the two. So it means that the domain of this is going to be from positive 2 to infinity. Like that. So if I have two domains, I get the intersection. I hope that is okay. Okay. The other case, here, the domain x a real number such that h of x should be greater or equal to 0 and g of x should be greater than 0. So on g of x, because it has gone in the denominator, we remove the equal to. We just say greater than 0. An example here is f of x is equal to the square root of x plus 1 over the square root of x minus 3. So here, the domain is going to be x, a real number, such that x is greater or equal to -1. From the top one, from the down one, x is greater than 3. and then you get the intersection again. So say this means that the domain is from 3 equals to infinity, where we do not include 3 because it's not included. We just have greater here. Okay?
Uh,
Hello.
yes, sir. Now let's say it was x is greater than or equal to 1, then x is greater than -3. We could have picked the positive one.
Yes, we have picked 1.
Okay, thank you.
Because if you put on the number line again, the other one is starting from -1, the other one from 3. And they're going the same direction, like that. You want to pick where you have both. Okay? So we now talk about case 5. So let's place this one. So here we're saying, here we say that the domain is going to be x, a real number, such that h of x is greater or equal to 0, and g of x is greater than 0. Let's come to this one. This one, the domain is x, a real number, such that h of x is greater or equal to 0, and g of x is not equal to 0. So because now g is not in the root, so it must just not be equal to 0. An example there, you have f of x is equal to the square root of x plus 1 over 2x plus 3. So you will say, okay, here what we don't want is this. We want x plus 1 to be greater or equal to 0. We also want 2x plus 3 not to be equal to 0. So the domain is going to be x, a real number, such that x is greater or equal to -1, and the x is not equal to -3 over 2. Like that. So you can pick the intersection. So you can see that this one, if you draw, you have -3 over 2 here and -1 here. So you don't want x to be that value. You want x to be this side. So it means that we can just say, oh, okay, the domain is from -1 to positive infinity. This is also allowed. Okay? This one, the domain is x, a real number, such that g of x is greater or equal to 0, but a plus the root of g of x again should not be equal to 0. The same denominator, we have mentioned two things. The first one is that, so here, the first one is that the denominator must not be 0. But then we also have something in the root. So it must not be equal to a negative value. It can be 0 because when it's 0, provided a is not 0, then the denominator is going to be 0. So be okay with that. And here also, the domain is x, a real number, such that g of x is greater than 0. We now say it's greater. We don't allow equality because that is the only thing that we have in the denominator. So these are the questions that we expect on domain. These are the main issues. The main issues. So when I do this, I've answered so many questions. So many questions on the domain. Let's talk about the range now.
So in short, when the numerator doesn't have a root, then it's not included in the domain.
Yeah, it's not important
So,
because its domain is all real.
okay.
Sorry, sir, come again.
So if the numerator is not in the root, then it's not part of our issues because its domain is all real. Okay, so these are the major ones. But we have other issues that arise. So we went as far as what? In numbering, we went as far as 7. So let's add. We could also have a function of this kind. F of x is a plus the root of g of x over h of x. 9, f of x is equal to maybe h of x up there over the absolute value of g of x. The other one is f of x is equal to the square root of the absolute value of h of x such functions. Well, you could also have a function of this kind, h of x over a plus the absolute value of g of x. How then do we get the domain? For the top one, the domain is going to be x, a real number, h of x not equal to 0, g of x greater or equal to 0. For this one, the domain is x, a real number, such that g of x is not equal to 0. So you go inside the modulus, and whatever is there must not be equal to 0 because this thing is in the denominator. Remember, the modulus can even be 0. In this one, the domain is all real numbers. Though it's in the root, there is absolute there. It's making any number that goes there positive. Then now I can get x squared. Watch out for this one. Have you seen? It's in the root, but any number you take in the absolute, it becomes positive. And so I'm no longer worried about it. This one, the domain is x, a real number, such that a plus absolute value of gx is not equal to 0. Examples. One. So I find the domain for f of x is equal to x plus 3 absolute value of x over x. Two, f of x is equal to the square root of 1 plus absolute value of x over 2 minus absolute value of x. The third one is f of x is equal to two minus the square root of x over 3 minus x. Okay, let's look at this. For the first one, the domain here is x, a real number, such that just the denominator is equal to 0. It's not allowed to be equal to 0. The denominator is not equal to 0. And the second one is x, a real number, such that first, the inside up there, it's just okay. Because any number you take here is going to be positive, and then you add the 1, so you always have a positive here. You can easily get the square root. But the down one, we have an issue. So 2 minus this guy, let's see if it can be 0. This is the same thing as negative that guy equal to negative 2, divide, and then divide by negative 1, divide by negative 1. So we have this equal to 2. So if the absolute value is equal to positive 2, that is not allowed. Okay, when is that possible? So we do not want x to be equal to plus or minus 2. So we are saying here x should not be equal to plus or minus 2. Why? Because if you take positive 2 in the modulus, you have 2 minus 2, which is 0. If you take negative 2 in the modulus, it will come out as positive 2. And so you have 2 minus 2 again. So we don't want that to happen. This one. Then 3, the domain is x should be a real number. This time around, x must be greater or equal to 0 because of this guy in the root. And down, x should not be equal to positive 3. So have you seen that inside here, if you draw a number line, you put 0 here, you are saying this should be the case. And then somewhere they are saying, no, not 3. So it means that we can go the way this to the right, but please don't include 3. That's what the other one is saying. Remove 3. So 3 has to be removed here. Like that. I repeat on question 2. On question 2, the denominator must not be 0. And if you get the denominator to 0, you are getting that the absolute value of x must not be equal to 2. But we see that if x is negative or positive 2, if you pick these two and put them in the absolute, they will give us positive 2. And positive 2 is here. So we don't want to have plus or minus 2 because when they go in the absolute, they will be neutralized. What you're saying here is this. The absolute value of negative 2 is 2. The absolute value of 2 is 2. So either ways, if you place a negative or a positive 2 here where the x, you get a 0 in the denominator. And we don't want that to happen. So we have specialized in the domains in this one. So let's come back and look at the range now. The range of varieties of functions. Again, so we can have a clue on how to get the range, because these are the questions that you're going to find in test 1. Find the domain. So questions that, look at this. The questions where you involve the numerator are questions when the numerator is in something. Like here, g is in the root, and the root does not allow a negative value. So we talk about it. This one is just standing on its own. So we are comfortable. It's not being affected by anything. Okay? This one, again, it was almost affected by the root, but lucky enough, it's always giving positive. So the root is okay. This one, we're okay with the numerator. There's nothing restricting. Okay. So let's come back and do the other piece. Now we'll talk about the range.